Hello, everyone. My name is Arash. I'm part of National Research Council of Canada. This project is in collaboration with Concordia University, and it's a part of a bigger project that we are doing. Basically, we are trying to connect beam schema through IFC and then link it with other use cases such as energy modeling and those sort of applications. But the focus of this session is basically I will be talking about how the HVAC data that is coming from BMS, we have been trying to basically integrate it with IFC, picking features that are not usually transferable between these two. So with time series and binary data is the focus of this presentation. So basically, let's start. What is feature sensitivity? How we define it? Basically, sensitivity analysis identifies those robust features that are critical for creating an automated fault detection and diagnostics. So fault detection is basically looking at if a fault is within an HVAC system, and that's where we call it that detection, fault detection, and diagnostic is basically identifying the type of the pain, basically the type of the difficulty that HVAC is having. No, the challenge that we are facing is within experimental setups and the real cases. We do have lots of sensors when it comes to the labs, but when we transition to the normal setups, we do not have those features, those sensors that can enable us to find those basically type of defects. So the focus is basically to see what existing features from BIM can come and assist us when we do not have access to all the features that usually we need for detection and diagnostics. So here what we do is basically we are leveraging BIM. We are going beyond what is the static schema. We are trying to look at it as a stateful BIM, where we say basically BIM will be used for applications that can track the changes over time. So that's the definition of stateful BIM. We look at that and we try to bring back that information after applying AFTD back to our schema. So we keep having the evolving IFC schema with extensions that are having those information with. All right, so within this project, this segment that here is focus of this conference presentation is we have taken a case study, a building which has an RTU type of HVAC on its floor. We basically modeled the BIM model from the specs that were available. We tried to identify features from it. What features could be as a candidate for incorporating those information that can represent the sensory data, basically the semantics. So the focus was to which information from BIM can hold those sensory information. We have 80 features basically identified. I'm not going in depth, but we had a pool of basically features that could have the live BIM transition that we were looking. We had already an existing 68 different features for BMS, that is temperature, humidity, so on and so forth, that are typically available within buildings. We have basically combined these features. Now we had a set of time series data, we had a binary set of information, that what we call it traditionally as static BIM. And what we have done within this project, at the end, the stateful BIM, what we call is basically we created a curated feature where we took parts of the schedule of the HVAC and combined it with the spatial information. So we took a room and we have connected it with HVAC schedule and the zoning information for that HVAC. So that's the focus of introduction of a new feature. We call it stateful BIM feature and introduce it. We had on the right side, you see another type of grouping we have done to identify basically the faults of HVAC. So some of them are system level, some of them are equipment level. We try to categorize. Basically, we are the intention here is to find which feature can be leveraged from BIM to be combined with BMS and have that fault detection and diagnosis. So basically, we have a mix of zone level information. We have system level information. system level and the entire building level. So three combinations of the approach. All right, so to do feature sensitivity analysis, we basically picked the most common available feature sensitivity analysis algorithms to identify which of these concatenated data set that we are having are having most impact for the HVAC system. As it is expected, within the first 10 or 15, we never found anything that basically contributes from BIM. So these are maybe the sensor data that is expected from an BMS data set. So most of the three algorithms that we use basically gave us what we were expecting, nothing beyond what we were hoping to have. That is our stateful BIM feature that was introduced that captures the zoning. But what is interesting in the next step on the right side, you can see it's not very clear, but we are having the two features basically that are spatially infused feature that we're having correlations in terms of there's not a strong correlation, but it was enough for us to try and pick those stateful BIM features and experiment with those features. So what we did is now we tried to train two models, machine learning models. One is a simple SPM model. We wanted to keep track of what we are having. So basically we tested, and as expected, we had our top 5 features again coming from the BMS. So these were the features that could be replaced with space air condition. We tried replacing with each of these, and we had an improvement of around 6 to 8%. That's not big. Some might call it just a big, just the experimental phase. The issue we had was the building is entirely instrumented. So in a real world, we know not all of the features are going to be controlled at all times. So we are hoping if these algorithms are transitioned to an existing building that basically is not monitored at all times, we can see improvement in that sense. Also, we have the results for neural network. Basically, we have the same order, but in a different order, we basically captured what could be the sensitivity of those introduced features. The interesting findings were basically the stateful BIM features that were extracted are more sensitive to artificial neural networks. So basically, the developed tool, basically in terms of BIM to BMS transition, it seems BIM these features can work in models such as ANN. So this is part of an we are going to have an ongoing investigation to transition these models to our existing buildings. We do have those. We want to try and see if that changes are captured within real scenarios. These are some of the findings which classifier basically works us best for the stateful BIM feature we have, and basically the recommendation in terms of which feature we can basically have replaced with the stateful BIM. So humidity was one of those that showed the most sensitivity, and it's a part of ongoing investigation to see how that would basically affect within a real case scenario. As I mentioned already, artificial neural networks was basically the model that gained the most accuracy increase in terms of when we had our curated data set, curated features introduced to the data. And also the most impact where we could find is the air humidity, the room temperature, and the discharge temperature. These are some of the features that has the most impact. So part of what we did is we tried to create a dynamic BIM, basically having to enhance AFDD by reducing. So we had 68 features. We tried to reduce it to 5 or 10. And we tried to experiment with one added feature from stateful BIM to see are we able to compensate what we are missing. So if in a real case scenario we do not have 68 features, can we replace it with one from the BIM and gain similar accuracy levels? So that's in a gist of what we are doing. These are some of the references we used, and Yeah, that's it. Thank you for your time and